Hey everyone, and welcome. Today, we're going to do something a little different. We're going on a journey, and we're going to follow a single piece of data from the very moment it's created inside your application, all the way through the OpenTelemetry pipeline, until it becomes a real, powerful insight. You ready? Let's dive in.
So, your application is live. You've pushed the code, it's out there, people are using it, but do you really know what's going on under the hood? I mean, really? When things start to slow down or something just breaks, are you kind of flying blind? Well, this is the exact problem that observability is here to solve, and it all begins with capturing the right signals from the start.
Every great journey needs a map, right? Well, here's ours. It's a pretty straightforward 4-step trip. We're going to start at the source, right inside your code. Then we'll see how it gets picked up by the SDK. From there, it goes to the central processing hub, the collector. And finally, it lands at its destination, the back end, where all the analysis happens. So let's get going. First stop, the source.
Okay, so our signal's life begins right here, inside your application's code. I'm talking about every single log, every performance metric, every trace of a user's request. It all starts from a specific line of code running at a very specific moment. But the big question is, how do we actually capture it? The answer is this thing called instrumentation. You can think of it like adding thousands of tiny little sensors directly into your code. Now you can do this automatically, which is awesome, where OpenTelemetry just hooks into big frameworks like Spring or Django, or you can get your hands dirty and do it manually to track really specific business logic, like maybe a process order function. Either way, once your code is instrumented, it starts sending all this juicy data to the OpenTelemetry SDK. That's its first stop on the journey out of your application.
So the SDK is sitting right there inside your app, gathering up all the data. That's step 2, our local agent doing its thing. But for that data to be really useful, it needs to be processed and sent off to different places. And that's where step 3 comes in. Our signal leaves the application and heads to probably the most powerful part of the entire OpenTelemetry world, the collector. Honestly, the best way to think about it is as a central sorting facility, like a giant post office for all your telemetry data.
Now, what's so cool about the collector is just how simple its workflow is. Data comes in, it gets processed, and then it goes out. If you remember just one thing about the collector, please let it be this mantra: receiver, processor, exporter. Seriously, this simple 3-step pipeline is the key to absolutely everything it does.
First things first, data has to actually get into the collector. That's the whole job of receivers. Think of them like loading docks at our post office. You can set them up to accept data in all kinds of formats. The standard is OTLP, but you can also have receivers for things like Prometheus, Zipkin, or even pull in streaming data directly from Kafka.
All right, so the data is inside. Now our signal moves on to the processing stage. And this, my friends, is where the magic happens. Processors are like the super efficient sorters on a conveyor belt. You've got the batch processor, which groups signals together to be more efficient. The memory limiter is like a bouncer, making sure things don't get overloaded. And then you have the attributes processor, which can enrich the data by adding crucial context, like a customer ID or a cloud region. Super useful.
And finally, our clean, processed, and newly enriched signal is all packed up and ready to be shipped out. That's the job of the exporters. These are the delivery trucks. You can configure one exporter to send your trace data over to Jaeger, another to send metrics to Prometheus, and hey, maybe a copy of everything to Datadog, all from the exact same pipeline.
You know, it's worth quickly mentioning that there are 2 ways this data can move. For things like traces, it's usually a push model, where your app is actively sending data to the collector. But for metrics, especially if you're a Prometheus user, it's often a pull model, where the collector actually reaches out and scrapes the metrics from your application. Just a little difference to keep in mind.
And just like that, our signal has arrived at its final destination. It has traveled all the way from the code, been processed and polished by the collector, and now it's ready to be transformed from just raw data into something a human can actually understand and use. This is the moment its value is truly unlocked. Now, this destination or backend can be any number of different tools. You might have an exporter sending traces to Jaeger for debugging, while another sends metrics to Prometheus so you can build Grafana dashboards, and maybe a third one sends all your logs to an ELK stack. The beauty is, the collector lets you send data to any or even all of them at the same time.
So we followed just one little signal on its journey. But let's be real, in the real world, you've got millions of these things flying around inside some really complex systems. So let's zoom out for a second and see how this whole pipeline scales up into a proper system architecture.
In a modern environment like Kubernetes, you've got options, which is always a good thing. You could deploy a collector as a sidecar right next to each microservice for isolated processing. Or you could use a DaemonSet to have one collector on every node watching everything. Or for the really big enterprise setups, you can have a central gateway collector that gathers telemetry from everywhere else.
And this, right here, perfectly illustrates one of OpenTelemetry's absolute biggest strengths. You can have services running in AWS, GCP, and Azure, all sending their data through one single standardized pipeline to any backend tool you want. And what's the result? No vendor lock-in. You are in control of your data's journey.
So why does all this matter so much? Why go to all this trouble to build this structured data pipeline? Because it's the foundation for the future. AI Ops, or AI for IT operations. When you have clean, correlated telemetry, AI models can start to do incredible things, like detect anomalies, predict failures before they even happen, and even trigger automated fixes.
And that's the ultimate goal, isn't it? When you have a solid data pipeline, like the one we've just walked through, your telemetry stops being just a big pile of random data points. It becomes active, actionable intelligence about the real health and performance of your systems.
All right, so let's wrap this up. What are the key things to remember? First, the collector is the heart of the system, and its flow is always receiver, processor, exporter. Second, this model gives you amazing flexibility, especially in a multi-cloud world, and it saves you from vendor lock-in. And finally, remember that this entire data pipeline is the essential foundation you need to build true, deep observability. By understanding this whole flow, from end to end, you're not just passively collecting data anymore. You're actively designing an intelligent system. You get to shape how telemetry moves, what it gets enriched with, and where it ultimately goes. So the real question is, what are you going to build with that power?